Today's lesson video is based on Physics 1501, Elementary Mechanics. This is May-June 2018. We are going to focus on question 7 of the second paper. Remember, we had the first paper and the second paper. This one is question 7 of the first paper. Let us start. This question is 10 marks, that is the mark allocation. We look at the scenario. A 42.0 kg seal at an amusement park slides from rest down a ramp into the pool below. The top of the ramp is 1.75 meter higher than the surface of the water, and the ramp is inclined at an angle of 35.0 degrees above horizontal. Is the seal reaches the water with a speed of, I believe there's a problem here. It was supposed to be if the seal reaches the water with a speed of 4.40 meters per second. What are? The first question says work done by kinetic friction, and the second question, the coefficient of kinetic friction between the seal and the ramp. Now, looking at the picture form of this question, remember, in order for us to solve questions, we need to at least construct a pictorial form of this scenario. So we have something like this. We take that this is our ramp, and then the angle is 35.0 degrees, and then this will be the water. We have the seal here. The initial velocity of the seal is 0 meters per second, since they say it slides from rest. And then the height of the ramp from here to here is 1.7 meters, 1.75 I mean meters. And then when the seal is here, that's where it reaches the water. We find that the velocity is 4.40 meters per second. Now, with this picture, we have an idea of what is happening. So the first question says the work done by kinetic friction. So it simply means that this ramp, it's not frictionless. There is friction. And then we are looking for the work done by friction. Now, this question is based on the topic, which is work, energy, and power. We have a number of equations we can actually use to calculate this work done by a kinetic frictional force. The first equation that we have is this one, whereby is the work done on an object, it's equals to the work done by that particular force multiplied by the displacement multiplied by cos theta. And then we know that this angle is the angle between the displacement and the force. There is lesson 101 whereby we look at the basics of work and how we apply the equations. So in this lesson video, we are just going to apply them. Now, the second equation is work net, it's equals to change in K, that is equals to half mvf squared minus half mvi squared. So this is the work energy theorem. And then the last one is this one, change in K plus change in U, that is half mvf squared minus half mvi squared plus mgh final minus mgh initial. Now, recalling the scenario, we have the mass of the seal, we have the final velocity, we have the mass, we have the initial velocity, we have the mass, we have the gravitational acceleration, we have the final height, we have the initial, the mass, the gravitational acceleration, we have the initial height. Now, looking at this work done by non-conservative forces, there's only one force which is a non-conservative force, that is the frictional force. So we can actually use this equation to calculate the work done by the kinetic friction, since it's the only force that is doing a non-conservative work to the object. We can also use this equation, but we need to understand that we have two forces which are doing work to the object, that is the gravitational force and the kinetic friction. But I believe you don't have enough data to actually use this equation, but we can also try it and check whether it will work, but this one is guaranteed that it will give us the correct answer. So we can go ahead and substitute, and then on the work done by the non-conservative force, we only have work done by kinetic friction, and then we have half the mass, it's 42.0, the final velocity is 4.40 squared, minus half. Now, to make things simple, we have point A, let's say this is point A, this is point B. This will be our initial position, this will be our final position. So the value of VF is 4.40, that is position B. And then now I'm focusing on position A, which the mass is still 42.0, the initial velocity is 0 meters per second, plus we look at the potential energy of the seal at position B. What is the height at position B? The height is 0, and then we still have the mass as 42.0. We know our gravitational acceleration is 9 point, and then we have the height as 0, minus the mass of the seal is still 42.0, and then gravity is 9.8, and then we have the initial height, which is this one, 1.75 meters. From here we can see that work done by kinetic friction, since we have 0 here, this will also be 0. We have 0 here, this will be 0. So we are left with 42.0, 4.40 squared, minus 42.0, 9.8, 1.75. So the work done by kinetic friction, it's equals to negative 3.74 joules. So this is the answer to the first question. The second question says we need to calculate the coefficient of kinetic friction between the seal and the ram. For us to actually calculate the coefficient, we need to calculate this side, which is the displacement. Now, since we can see that this is a right angled triangle, we can use trigonometric ratios to calculate this side. Now we look at the expression that involves the opposite side and the hypotenuse, and then the expression is sine So sine theta is equals to opposite over hypotenuse, or we can say it's y over r. Now in this case, the value of the angle is 35.0 degrees equals to the opposite, it's 1.75, and then we are looking for the hypotenuse. We can say the hypotenuse is d, or change in x, but it's fine if you put d. Now we multiply both sides by d. This will get rid of this. Then from here we divide both sides by sine 35. So d is equals to 1.75 divided by sine 35.0. We find that d is equals to 3.05 meters. We are going to use this, and then from here we can use the work done by kinetic friction. It's equals to the kinetic friction multiplied by the displacement, or let us put, since we are using d, cos theta. We know that the angle between the displacement and the kinetic friction is 180, so we have work done by kinetic friction is equals to Fk d cos 180. Then from here we know the value of the work done by kinetic friction. It's negative 313.74. And then the kinetic friction, we are looking for it. The distance is, or the displacement is 3.05, and then cos 180 is negative 1. So basically we have negative 313.74 equals to negative 3.05 Fk. So we divide both sides by this. This will result into 1 multiplied by Fk. We have Fk is equals to 102.87 newtons. That is the kinetic friction. Then from here we know the equation of kinetic friction is this multiplied by normal force. Now the normal force on an incline, we know that the equation of normal force is equals to mg cos theta. Lesson 101, it explains everything, how come this equation is applicable in this situation. Now to express this, we have Fk is equals to coefficient multiplied by mg cos theta. And then we know the value of Fk is 102.87 equals to, we are looking for the coefficient. The mass is 42.0. The gravitational acceleration is 9.8. And then we have cos. The incline is 35.0 degrees. So we can divide both sides by 42.0, 9.8, cos 35.0. We have 42.0, 9.8, cos 35.0. So this will result into 1. Then we are left with coefficient is equals to all of this. 3, actually it's 0.305. Remember, there's no SI unit for the coefficient, so this is the final answer. That's it for this lesson video. This is Wahula SJ. Thank you very much.